So here they're asking for the length of this arc, and so we call that arc length. Now, for whatever reason, they label arc length with S, but this formula is really key, where S is equal to r theta. Now, I'll show you another approach that you could use without memorizing the formula, but I personally think that it's easier just to go with the formula. Now, a key thing to notice is they give us the 20-degree measure. However, that central angle corresponds with arc XZ. Notice that they want you to find the length of arc XYZ. So that's from X all the way to Y. And notice I went in that direction because you need to end up at Z. So if this is 20 degrees and a full circle is 360, we know that this remaining part is 360 minus 20, so 340 degrees. So let's go ahead to this formula where the radius is 10 all throughout a circle, and theta has to be in radians. That's really important to keep in mind. So we currently know it in degrees, and we're going to have to go ahead and convert it to radians. Now you'll recall on page 35, so side 5 of our math reference document, we have all things trigonometry up here. Now in the upper right corner we have the conversion, and keep in mind just like 12 inches is equivalent to 1 foot, 180 degrees is equivalent to pi radians. So when you're converting to radians, you want the radian measure on top. In other words, pi over 180. If you want it in degrees, you want the 180 on top, so 180 over pi. Now in this case, we want it in radians, so we're going to multiply by pi over 180. I like to put this over 1 so that you can see that you have fractions that you could cross cancel by dividing by 10. We could continue to simplify, but let's go ahead and just put it in our calculator to avoid any silly errors. And you could obviously use Desmos as well. I'm just a big fan of my calculator at this point. And then I like to do a fraction, alpha y equals, press enter, type in the 34 or 340 over 18 or 180, depending how we kept it. And then notice it simplifies it for me to 170 over 9 pi. So I have the pi here. I obviously didn't put it in the calculator just yet, but because of the fact they want this rounded to the nearest tenth of an inch, I need to actually put it in my calculator. So I'm going to put times pi, and then we get our answer, and let's go ahead and do the rounding, and then we'll look at the other approach. So because they want it to the nearest tenth, we go to the tenth place, which is this 3. You always look to the right of whatever place you're trying to round to. A 0, 1, 2, 3, or 4, like we have here, says to stay, which keeps the answer right here. A 5, 6, 7, 8, or 9 would have said round up. So we get our answer is 59.3, and we're totally done. However, you could have thought of this as, well, if this is 340 degrees, and I know that that represents a fraction of the overall full circle, you could say, okay, that's a fraction of, and remember, as we see on the back side of page 33, so side 2 of our math reference document, certain key words exist, including of, meaning to multiply, not to be confused with out of, which means divide. So when we say of, we're multiplying, so this fraction of the overall circumference. Now we probably know by now the circumference formula is 2 pi r. If you didn't, you could pull up the reference document and you'll see it right here below the area formula. So circumference is 2 pi r. What's going on? And so if we go ahead and multiply this out, let's replace the r here with a 10. And I'm going to keep the pi just the way that it is. So let's go ahead and say if we put this in the calculator, 340 over 360 times 2 times 10. Hey, that should look familiar, right? So you can see you get the same answer eventually if you multiply by pi. But again, I'm a big fan of memorizing the formula as s equals r theta. But regardless, we get our answer is 59.3.